So let us discuss this example. So in this example, we have to find out one open ball. As you can see here, we have to find out this open ball with center at origin, okay, and radius is 1. But see, what is a metric here? So metric is d infinity. So d infinity is induced by this norm infinity, and norm infinity, its definition is also mentioned there, right? So we will follow the definition of open ball and we will try to find, okay, we will try to find its diagram also in R2. So let us start. See, definition says, okay, so B, open ball with center 0 0 and radius 1. So definition says it contains all elements of R2. It contains all elements of R2. You remember the definition of open ball. It contains all elements of R2 such that distance of that point from the center of ball should be less than its radius. That means less than its 1. Such that d xy comma 0 0, okay, is less than 1, less than r actually, but r is 1 here. And one more thing, so d, that means d infinity here, since precisely they have mentioned we have to use d infinity. So this is equal to xy belongs to R2, okay, belongs to R2 such that d infinity, what is the definition of d infinity? Say d infinity is induced by norm infinity. That means d infinity is defined with the help of norm infinity. You remember that means when we have a metric which is induced by some norm, what we do? We write in this way, norm xy minus 0 0 infinity less than 1, okay, in this way. So this is equal to xy belongs to R2, okay, belongs to R2 such that norm coordinate wise subtraction we need to do. X minus 0 we will have x, y minus 0 we will have y, infinity less than 1, okay. So that means we have got this thing. So now we are we can use that definition of norm infinity. So tell me, what can I write using definition of norm infinity? Xy belongs to R2 such that definition says maximum of. So here also I should write maximum of mod x1. So here mod x, correct, comma mod x2, and that means if we have x1 x2 we write mod x1 comma maximum mod x1 comma mod x2. But when we have xy, obviously we write maximum of mod x and mod y. This is less than 1, right? See, but what is maximum? What is maximum of mod x and mod y? So that means we don't know the values of x and y, so that's why we cannot decide. But definitely we can say maximum of these two is either mod x or maximum of these two is mod y. So this is mod x and or I will say mod y. That means either we will have its value is mod x or we will have its value is mod y, right? So here we have strictly less than. But see, when we draw the diagram, we need to consider equality. And after drawing diagram, we can decide which region is mentioned there. So here also I will consider equality there, okay, and after that we will decide the region, okay. So see, therefore given region is bounded by so as I told you, its value is either mod x. So that's why mod x is equal to equality I am considering here, getting now. So without equality we cannot draw the diagram, and mod y is equal to 1. So since its value is mod x or mod y, so if it is mod x we will have it is mod x is equal to 1, and when its value is mod y we will have mod y is equal to 1. So region is bounded by mod x is equal to 1 and mod y is equal to 1, okay. We will go further, but before that make a screenshot of it, and after that we will solve the problem, okay, please. So therefore we can write, therefore we have what we have, mod x is equal to 1 and mod y is equal to 1. So mod x is equal to 1, that means value of x can be plus minus 1, and mod y is equal to 1, that means mod is there, that means plus minus both signs will be there. So therefore implies I can write x is equal to plus minus 1 and y is equal to plus minus 1. So then we will consider all equations. That means x is equal to 1. X is equal to 1, this is a line parallel to y-axis passes through x is equal to 1. Simply I will mention a line parallel to y-axis. Okay, here I will draw the diagram and show you. So this is y-axis, this one is x-axis. Okay, this is y-axis and x-axis. Here is 1, here is minus 1, 1 and minus 1. So x is equal to 1, a line parallel to y-axis. So this is x is equal to 1. So this is x is equal to 1. So maybe you will think that why I have drawn their dotted line, because equality we have assumed. Actually we had got less than, strictly less than, you remember na? So equality we have assumed, so that's why actually there is no equality, so that's why I have drawn their dotted line. Okay, see, now x is equal to minus 1, x is equal to minus 1, this is also line parallel to y-axis, but it passes through x is equal to minus 1. That means this line we can draw. Okay, so this is our x is equal to minus 1. Next is y is equal to 1. Y is equal to 1, a line parallel to x-axis. Okay, so y is equal to 1, a line parallel to x-axis. So this is y is equal to 1. Okay, y is equal to 1. And the next one is y is equal to minus 1. So this is also a line parallel to x-axis, but it passes through y is equal to minus 1. So this all lines we have considered here. So that means region bounded by these 4 lines. So this is a given region. So you can easily tell me. So this is a given region. Okay, you can see on the screen now. So region bounded by these 4 lines. What do you think? What do you think? We have to consider boundary or not? We cannot consider boundary here. We cannot consider this boundary because we had got strictly less than region lies inside these 4 lines. Okay, when we have equality there, then that means on boundary, and when we have strictly greater than, that means outside. So in this way we have got this one. Okay, so this is an open ball. Okay, normally what we think when we consider open ball, we consider a circle, but it is not a circle. We have got a square here. Okay, so make a screenshot of it, and after that we'll stop. Thank you. Bye bye.